Hello students, we were doing applications of derivatives, problems based on maxima and minima कर रहे थे हम. Let us start with the next question. A figure consists of semicircle with a rectangle on its diameter. Given the perimeter of the figure, find its dimension in order that area may be maximum. Figure is given. Semicircle on the rectangle A, B, C, D. This is given 2x and 2y. Write down. Let A, B, C, D be a rectangle. Let A, B, C, D be a rectangle and semicircle be described on side AB as diameter. This side is 2x and this is 2x. Diameter is 2x and the radius will be x. Now perimeter. What is the perimeter of rectangle? 2 times length plus breadth. Rectangle के लिए और semicircle. Perimeter of the circle is 2 pi r. Semicircle is pi r. यही होगा. बट जो रेक्टेंगल की ये साइड है ये एज अ डायमीटर सेमी सर्कल ड्रॉ करने के लिए भी यूज हो रही है. तो पेरीमीटर ऑफ रेक्टेंगल में हम ये वाली साइड इंक्लूड नहीं करेंगे. सो 2x प्लस 2y प्लस 2y 2x प्लस 4y प्लस पाई r. क्लियर? हमने ऐसा क्यों लिखा? बिकॉज जो रेक्टेंगल की एक साइड है वो सेमी सर्कल ड्रॉ करने के लिए एज अ डायमीटर यूज हो रही है. तो हम एक ही साइड को 2 बार तो पेरीमीटर में इंक्लूड नहीं करेंगे टोटल फिगर के. इसलिए पेरीमीटर ऑफ रेक्टेंगल विल बी 2x प्लस 2y प्लस 2y प्लस पेरीमीटर ऑफ सेमी सर्कल पाई r. नाउ एरिया. एरिया ऑफ रेक्टेंगल इज लेंथ इंटू ब्रेथ प्लस area of circle is pi r square. So semicircle is 1 by 2 pi r square. That is x square. So area is equals to 2x into 2y plus pi r square by 2. Clear? Now in the next step 4xy. Find the value of 4y from equation 1. We get 4y is p minus 2x minus pi x. Put the value of 4y. p minus 2x minus pi x plus pi x square by 2. So we get px minus 2x minus pi x square plus pi x square by 2. px minus 2x square 1 by 2 minus 1 minus 1 by 2. So this is the value of area. Now differentiate dA upon dx. Derivative of x is 1. 4x minus 2 pi x by 2. So p minus 4x minus pi x. Now second derivative minus 4 minus pi. So second derivative is negative. Now we have to find the value of x. So put first derivative equal to 0. dA upon dx is equals to 0. p minus 4x. From here we have to find the value of x. x is p upon pi plus 4. और अगर हम इस पॉइंट पे भी सेकेंड डेरिवेटिव देखें तो डेट विल बी नेगेटिव. नोट अप टू हियर फर्स्ट. d square a upon dx square at x is equals to p upon pi plus 4 minus 4 plus pi less than 0. Therefore A is maximum when x is equals to p upon pi plus 4. Now we have to find the value of y. We have 4y is equals to p minus 2x minus pi x. यही वैल्यू थी हमारे पास फर्स्ट इक्वेशन से, p minus 2x minus pi x. Put the value of x here to find the value of y. X is p upon pi plus 4. P upon pi plus 4. Take the LCM. P pi plus 4p minus 2p minus pi p. This will get cancelled. So 2p upon pi plus 4. This is the value of 4y. So we get y as 2 upon p upon 2 pi plus 4. P upon 2 pi plus 4. Therefore, write down, therefore, area of the figure is maximum. Area is maximum when length 2x, 2p upon pi plus 4 and breadth 2y, p, 2 will get cancelled, p upon pi plus 4. Clear? Therefore, area is maximum when the dimensions are 2p upon pi plus 4 and p upon pi plus 4. Volume of the largest cylinder that can be inscribed in sphere of radius r. Cylinder is inscribed in sphere. Let the radius of cylinder is denoted by capital R and this height is h. And the radius of sphere is given small r. Write down, let h be the height and r be the radius of cylinder. Now, when this height is h, then this is h by 2 and h by 2. Let V be the volume of cylinder. Volume of cylinder is pi r square h. Let it name as A, B, C, A dash, B dash, C dash. In triangle AOC, r square is h by 2 square plus r square. By using Pythagoras theorem, from here we can find the value of capital R. Here, put this value here, pi r square h. So pi r square h minus pi by 4 h cube. ये आया हमारे पास. Now differentiate it with respect to h. Pi r square, pi by 4, 3h square. Now find the second derivative. 3 pi by 4, derivative of h square is 2h. So minus 3 pi by 2h, that is less than 0. Put first derivative equal to 0. Pi r square is equals to 3 pi by 4 h square. R square is 3 by 4 h square. Or from here we can find the value of h. 4 r square by square v upon dh square at h is equals to 2 upon root 3 into r. 2 root 3 r minus root 3 pi r, that is less than 0. It means volume is maximum. Volume is maximum when h is equals to 2r upon root 3. Find the value of r square minus h square. 3 minus 1, 2r square by 3. And in the next step, we get r as root 2 upon 3 r. Now the maximum volume is pi r square h. Put the value here, value of r and h. R is r square 2 by 3 r square. H is 2r root 3. So 4 r cube 3 root 3 pi. And the maximum volume has value 4 pi r cube upon 3 root 3 cubic units. Next one is, show that the cylinder of given volume which is open at the top has minimum total surface area provided its height is equal to radius of base. And surface area we have to prove minimum. Let r be the radius and h be the height of cylinder. Volume of cylinder is pi r square h. Surface area of cylinder is 2 pi r h plus r. That is 2 pi r h plus 2 pi r square. But it is open at the top. इसका top जो है that is open. Therefore, instead of 2 pi r square, here we will have pi r square. Clear? Why we have pi r square here? वैसे surface area का formula ये है, but since it is open at the top, therefore we have pi r square plus 2 pi r h. Now put the value pi r square. Put the value of h here. H is v upon pi r square. So pi r square plus 2v upon r. Now differentiate it with respect to r. 2 pi r plus 2v. Derivative of 1 upon r is minus 1 upon r square. Put this derivative equal to 0. 2 pi r is equals to 2v r square. 2 will get cancelled. R cube is equals to v upon pi. Put the value of v here. V is pi r square h. So r is equals to h. First condition हमने प्रूफ कर दी. उसने कहा था कब कंडीशन, जब हाइट और रेडियस ऑफ बेस विल बी इक्वल. नाउ फाइंड द सेकंड डेरिवेटिव. Derivative of this is 2 pi minus 2v. Derivative of r minus 2 upon r cube. Find the derivative when radius is equals to height. Minus minus plus 4, value of v pi r square h r cube. H is equals to r. So put here. So r cube upon r cube 6 pi, that is greater than 0. Therefore surface area is minimum. अगर सेकेंड डेरिवेटिव 0 से ग्रेटर है then it is minimum. Surface area is minimum when height is equals to radius of the base. Now next one, show that height of the closed cylinder of given surface and maximum volume is equal to diameter of its base. We have to prove that it is equal to diameter. Diameter means 2 times radius. Surface area, total surface area of cylinder is 2 pi r square plus 2 pi rh. And volume of cylinder is pi r square h, right? Let r is the radius and h is the height of closed cylinder. Let r be the radius and h be the height of closed cylinder. Surface area is this. From here find the value of h. S minus 2 pi r square upon 2 pi r. यही आई हमारे पास h की वैल्यू. Volume of cylinder is pi r square h. Put the value of h here. 2 pi r square upon 2 pi r. So we get s r by 2 minus 2 pi r cube by 2. So s r by 2 minus pi r cube. This is volume. Now we have to prove that surface and maximum volume. Volume is maximum. Differentiate it with respect to r. Surface area has some constant value. Therefore, s is constant. Derivative of r is 1 minus 3 pi r square. Now put first derivative equals to 0. dv upon dr is equals to 0. S upon 2. 3 pi r square. So we get s as 6 pi r square. Now find second derivative. Derivative of s is 0 minus 3 into 2 6 pi r minus 6 pi r. So it is less than 0. Put the value of s here. Let this equation as 2 and this as 1. S is equals to 2 because we want to prove that h is equals to 2r. So put the value of s. 2 pi r square plus 2 pi rh is equals to 6 pi r square. 6 minus 2, 4 pi r square. Pi will get cancelled. 2. So rh is equals to 2r square. We get h is equals to 2r. That is height is equals to diameter. यही हमें प्रूफ करना था कि वॉल्यूम इज मैक्सिमम व्हेन हाइट इज इक्वल्स टू डायमीटर. h is equals to 2r. Now in the next step, second derivative, d square v upon dr square at h is equals to 2r. It is also equals to less than 0 minus 6 pi r. It is less than 0. Therefore, volume is maximum when height is equals to diameter of the base. Clear? Therefore, volume is maximum when height is equals to diameter of the base. Next one, show that height of cylinder which is O base. We have to prove height is equals to radius of the base. Now surface area, it is cylinder is open at the top, therefore pi r square plus 2 pi rh. हमने पहले भी पढ़ा था टोटल सरफेस एरिया का, वैसे हमारे पास सिलेंडर का क्या फॉर्मूला है 2 pi r square plus 2 pi rh. Since it is open at the top, therefore 1 pi r square will be less here. Now volume of the cylinder is pi r square h. Let r is the radius and h is the height of cylinder. From here find the value of h. S minus pi r square 2 pi r. Put the value of h here. S minus pi r square 2 pi r. So we get SR upon 2 minus pi r cube upon 3. Find the first derivative. S upon 2 minus 3 pi r square by 2. Put first derivative equal to 0. S upon 2 is equals to 3 pi r square by 2. Now put the value of S. Pi r square plus 2 pi rh is equals to 3 pi r square. 3 minus 1 is 2. That is equals to 2 pi r square. 2 pi will get cancelled. 1 r is cancelled. So h is equals to r.